Here's an example of a real MCAT CP passage question with expert feedback. Compared to micellular compound 1, compound 2 is structurally more rigid as a result of what type of interaction? A. Intermolecular hydrogen bonding. B. Intermolecular covalent bonding. C. Intramolecular hydrogen bonding. D. Intramolecular covalent bonding.
So question 1, compared to the micellular compound 1, compound 2 is structurally more rigid as a result of what type of interaction? Did you have any ideas behind this answer?
Well, looking at the compound, I noticed a lot of oxygens and nitrogens kind of sticking out. So I figured there could probably be some kind of hydrogen bonding instead of covalent. And then I figured if it's like creating a solid, that would be like intermolecular, not intra, like within the molecule itself. But I guess that's wrong.
Yeah, so here the thing that I would kind of point out is both paragraph 3 and paragraph 4. And so I'm actually going to open up a whiteboard because we're going to use this paragraph 3 quite a bit. So there we go. So I've copied it in here. All right. So even just going through this passage, kind of paragraph by paragraph, that first paragraph here kind of just highlighting the composition of bone. Compared to the questions, this paragraph ends up not being too relevant. But paragraph 2 here kind of talks about compound 1, how it's similar to bone. Once again, not really relevant to the questions, but that's how we can use our summaries to find things that do help us. Paragraph 3 talks about the different regions and gives us this figure which shows the different amino acid groups. So this paragraph will definitely be very helpful. And then for this question in particular, it talks about the reaction, and paragraph 4 talks about some of these reactions. So our first hint is in paragraph 4, where we have this oxidation of self-assembled micellular compound 1 with iodine results in the solid compound 2 material. So our first hint is that we have an oxidation reaction occurring. Our second hint that we have is in this paragraph 3, which I've copied, and it gives us these different regions. And so just going through these regions, so we start off and we have this hydrophobic region. So what is typically hydrophobic?
Like the tail that's like CH3 and CH2s.
Yep. So we have that hydrophobic region. And then we have residues that could be cross-linked for additional structural integrity. What area would that be?
The SHs?
Yeah, so it does end up being the SHs. And these are cysteine groups. And these are actually really important groups because when we have these, sorry, let me pull up a pen real quick. So
like the sulfide bridges, right?
Yeah, exactly.
Mm-hmm.
Sulfur bonds, like so. So that's just connected to the rest of the molecule. When we do an oxidation reaction, we form those disulfide bridges, as you had mentioned. And so combining that oxidation reaction that was mentioned with our information that we're given leads us to pick, this interaction from occurring. And what occurs is, of course, an intermolecular covalent bond. And it'd be intermolecular because we kind of have this combination of all of these compound 1s. And it would also be much easier for the compound itself to interact with another molecule of itself rather than reacting within the molecule. Just based on the space in here, all of these residues are rather close to one another. Does that make sense?
Mm-hmm.
Incorporate these tips and strategies into your MCAT independent study to score in the 90th percentile or higher in the CP section.